Hey YouTube, welcome back. Today we have the problem called Roman to integer. This is the second approach. Before I talk what was the first approach, let's just try to talk about the problem and discuss it again from the beginning. So the problem is saying that we have the Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. So I is equals to 1, V 5, X 10, and L is 50, and C is 100, and D is 500, and M is 1000. And we want to say, for example, 2 were written by 2 I's represent in Roman numeral, just 2 ones added together, and 12 is represented by XII, so basically 10, 1, 1, which is simply x plus II, or x plus 2, or 10 plus 2. The number 27 is written as XXVII, which XX is 10, 10, which is 20, V is 5, and II is another 2. We think that the Roman numerals are usually written largest to smallest, from left to right. However, the numeral for 4 is not 4 I's. Instead, the number 4 is written as IV, like that, IV, because the 1 is before the 5. We subtract it, making 4. So we take 1 from 5 to make it 4. The same principle applies to the number 9, which is written as IX, 1, 10, which when we take 1 from the 10, it will be 9. There are 6 instances where the subtraction is used. For example, we have I can be placed before V and X to get for us 4 and 9. We have X is 10, can be placed before L, which is 50, and C, which is 100, so we can take 40 and 90. C can be placed before D, which is 500, and M, which is 1000, to take 400 and 900. And we wanted to have the function that takes the numeral number, and after that as a numeral string, and after that we return a number. So for example, we have 3 I's. With 3 I's together, we have 3. This LVII, the L is 50, the V is 5, 3 I's is 3, so it's 58. We have the number this string, it's 1994. M is 1000, CM is 900, because M is 1000 and C is 100, and we just subtract it. XC, which is 90, the C is 100, X is 10, so it's 90, and IV is 4, V is 5, and I is 1, so it's subtracted. So we said that in the previous video, we talked about this solution, that we create a map table, and inside this map table, we try, inside this table, we store all the values of the numeral numbers, and we created a while loop, and in this while loop, we will loop through the numeral Roman string. And for this numeral Roman string, we take each character and we add, we see what is the number equivalent to it in this table, and add it to the sum. But before we do that, we wanted to make sure that we don't have the case where is maybe you have number 4, 9, or 4, 9, or 40, 90, or 400, 900. Because to solve that, we want to make sure that the numbers are like the current number is bigger than the next number, and when the number is not bigger than the next number, that means it's one of the that means we have one of the special 6 cases. And as you can see in this if else statements, we just try to shows that. So we say that if the current value is smaller than the next value, so for example we have IV, for example IV, and the I is equals to the I is 1 and V is 5. So that means the current value, if the current value was I, the next value will be V, which will be 5. If these are together are small, if this condition is true, that means we have one of the 6 conditions. So what we do, we take the next value and we take from the current value. So V minus I, it will be 4, and we increase I by 2 because we already have looped through the 2 elements. So this way was quite good. However, there is a way to improve this way, which is, why don't we store all the 6 conditions? Like for example this way, if I also stored all the 6 conditions, and instead of having the second if statement, okay, instead of having the second if statement, because it looks quite not that good to read, it's not that best to read, so why not to put the other 6 statement, the other 6 special statement, and instead of having the 2 if statements, we can have something different. I could just say I would say if I will have the current value as, let's just delete everything here. Let's just delete everything here, and let's just say that, because I will try to make a new thought from it. So first I will say if I is less than is the length minus 1. That means we have at least 2 number to loop through. If that was true, I want to make sure that we don't have one of these 6 cases. So like we don't have IV, IX, IX, or like I want to show do the next number, or do we have one of these 6 cases or not. So let's just try to see how we can do this. So let's just give const, I will call it double, let's call it symbol, equals is not substring I and I plus 2, sorry, and I will say if the double symbol, if the values that has this double symbol, a value that has, oh no, this double symbol, okay, if the value that has this double symbol, that means we have one of the 6 cases if the value has these double symbols. And if this was true, we will say sum plus equal values that get the double symbol. Okay. Otherwise, if that wasn't the and I will increase I by 2 as always, plus equal 2. Okay, and I will continue looping. Okay, and yeah, I will continue looping, and let's say otherwise, the length, otherwise it must be the maybe the length minus 1 case or something like that. I'll say const single, let's call it single symbol, equals is dot substring I and I plus 1, and I will say I, oh not I plus 1, and I will say the sum will plus equal values dot get. Or you could also, instead of making a substring, to make it easier, you can make it I of s of I values dot get single simple and I plus plus I plus 1. So I plus equal 1, and I'm returning sum as usual. Wait a minute, I will close the window because there is a helicopter outside. Sorry for the noises. It's unimaginable. It's really a lot of fucking noise. Anyway, so where we are, I forgot what I'm going to say. I hate that one. Yeah. Okay. So what we're doing here, let's just try to describe. So first of all, we store all of the numeral Roman numbers, symbols, and also we stored all the 6 special cases. And we try to loop through the string, and we say that, okay, so first, if I dot length minus 1, it's small than, if I small than s dot length minus 1, that means we have at least we have 2 symbols to loop through. So I just try first to loop through these 2 symbols, and if these 2 symbols are in the table, that means we have one of these 6 special cases. If that wasn't the case, like nothing happened, so we continue looping. And after we continue loop, we have the single symbol, and we have the number case, the single symbol, which is b substring I and I plus 1. Maybe you could also do it like that. Maybe this will be easier for us. Of I, this also could work, but I'm just trying to show multiple ways for the same thing. And this is how the substring work. And I just get the value of this symbol, and I increase I by 1. So let's just try to run it first. I have error. Let's run again. It was accepted, so let's just submit it. Oh, sometimes Leetcode takes too much time to submit the code. Like when I run it, it was accepted. Otherwise, they take too much time to submit the code. What's going on, Leetcode? What's going on with Leetcode? Maybe Leetcode cracked, or what's going on? Yes. What's going on? Let's refresh. Let's see. Did they accept my submission? Yeah, they accepted it. Let's just see the results. I'm beating 67. I suck in that. I don't know if suck in that is right or what, but like, okay, that was good, because the previous one, which is the previous video, we were, okay, sorry. I can't go back. Okay, so the previous video, we were beating only 24%. Right now we're beating 67%, which, whoa, it's good. Okay, so I such love that moment when you have a specific solution and you find this solution just beating a lot of different solutions. I feel I'm a good developer, and I needed this feeling right now because I had such an awful experience today in work. It wasn't the best way in work at all. It wasn't the best day. It was a pretty tough day. Anyway, yeah, that's it for today's video, and I hope that My description is quite good, my solution is quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you in future problems.